Hi guys, I'm Sudarshan Tamang. Today I'm going to give a presentation about wireless mesh radio or wireless mesh network. Mesh radio is an innovative approach to delivering broadband access to residential and small business customers. It is a network topology in which each node relays data for the network. All nodes cooperate in the distribution of data in a network. It is a new broad-based wireless access architecture that avoids the limitation of point-to-multipoint systems. It is independent of any existing service provider. The self-healing capacity enables a routing-based network to operate when one node breaks down or a connection goes bad. As a result, the network is typically quite reliable as there is more often more than one path between a source and a destination in the network. A series of point-to-point links are set up between nodes mounted on a customer's homes, avoiding the cost of conventional base stations. Each subscriber is linked to several other subscribers nearby by lower power radio transmitters. This in turn connected to others forming a network or mesh. It is used to increase the reach of cable networks without incurring the expense of digging up streets. Let's talk about wireless mesh network. It was originally developed for military applications. It is a communication network made up of radio nodes organized in a mesh topology. The coverage area of radio nodes working as a single network is called mesh cloud. Wireless mesh network can be implemented with various steel technologies, including 802.11, 802.16 cellular technologies, or combinations of more than one type. Each wireless device is capable of acting as a router as well as an end station. Packet routing is similar to the way packets go around the internet. The number of links between any two nodes are potentially much greater than in a wired network, since the actual configuration of a particular wireless mesh did not be determined until it is actually moving data. Paths through the network can change from moment to moment in response to varying traffic loads, radio conditions, etc. This is the layout of a mesh network. There are three types of configurations of mesh radio. One radio mesh, second one is dual radio with one radio backhaul mesh, and the third one, three radio with two radio backhauls mesh. Let's talk about one radio mesh. This configuration uses one radio channel both to service clients and to provide domestic backhaul. This provides more service of all options since both backhaul and service compete for bandwidth. This architecture suffers from the send-receive wait cycle. This is the figure of one radio mesh. Now next is dual radio with one radio backhaul. It is referred to as 1 plus 1 network since each node contains two radios, one to service provide or to the clients and one to create the mesh networks for backhaul. The 1 plus 1 name indicates that these radios are separate from each other. These two radios can operate on in different bands. This is a figure about the dual radio backhaul mesh. The third one is 3 radio with 2 radio backhauls mesh. This architecture provides separate backhaul and service functionality and dynamically manages channels of all the radios so that all radios are on non-interfering channels. It provides better performance of any options. This is the figure of 3 radio mesh. A single radio backhaul cannot send and receive messages simultaneously. Only multi-radio backhaul can do it. There are three types of broadband wireless network topologies. These are point-to-point topology, point-to-multipoint topology, mesh topology. Mesh topology is also known as multipoint to multipoint topologies. Point-to-point topology. Two buildings connected directly to one another through point-to-point connection communications link. For situations where long-distance links are required, a point-to-point architecture may be the best solution. It provides the highest data rates. Each communication link consists of an individual pair of broadband wireless routers and requires a dedicated user radio frequency channel. Here you can see a point-to-point link. Next one is point-to-multipoint topology. It allows multiple remote buildings to share a connection back to a single central base station. It is easily scaled up of the network. It causes hidden transmitter interference. To address this problem, some base station products can operate in a polling mode. This is the figure of mesh topology. It is referred to as a peer-to-peer or multi-point to multi-point topology. It enables network expansion, it provides a safe self-healing architecture, and reduces implementation and operating cost. Let's compare between these topologies. A point-to-point network is highly reliable, but it has low adaptability, and scalability is almost none because it consists of only two endpoints. Point-to-point, point-to-multipoint topology is low in reliability and low in adaptability, but it's moderate in scalability, as it consists of up to 30 endpoints. Mesh network topology is highly reliable and highly adaptable, and yes, it has very high scalability. It consists of thousands of endpoints. Mesh radio architecture has a flexible architecture. It is based on mesh networking or multi-hop networking for moving data efficiently between devices. In a multi-hop network, any device with a radio link can be served as a router or an access point. Here in this figure, it's an architecture proposed by Radiant Networks in California. Here, trunk network connection points, TNCPs, uh, link the radio access mesh to turn communications network. Each of these TNCPs will serve as a number of insertion points. MIP, this consists of standard customer node, CN, which can set up the connections to other customers and equipment for multiplexing the signals to and from that customer node onto a link to the TNCP. Customer node not only provides service for that customer but also handles transit app traffic from other customers. It consists of an outdoor radio unit and an indoor service presentation unit. The mesh also will also include a number of seed nodes. These are the same as the customer node except there are no customers connected to them. The operator installs them at a strategic locations to extend coverage to a large number of potential customers. The role of a seed node is to establish the path back to MIP. It's perhaps via another seed node. It is therefore at least one line of sight to an MIP or another seed. Let's talk about the advantages of mesh radio. With mesh radio, each new customer only needs to be within sight of at least one another customer, not within line of sight of the base station, as with other technologies. It is no longer necessary to deploy network connection points on the highest buildings or hilltops. In a single hop network, if the stalled access point goes down, so does the network. This is a robustness property. In mesh network architecture, if the nearest access point is down or there is localized interference, the network will continue to operate. Data will simply be routed along an alternate path. With traditional fixed wireless system, coverage even to a few subscribers, system depends on installing a significant number of base stations so that an operator is faced with high initial cost. With mesh radio, new customers can be connected with very low density of deployed seed nodes which provide initial coverage. Meshes are very adaptable to failures in nodes or dropouts in radio coverage. Traffic is simply rerouted dynamically. Each mesh node is aware of the primary optimal path, the secondary path, and a very tertiary path a packet may follow to reach its intended destination. If a building node is removed from the network, each node rapidly learns of the change and defines a new optimal path for its traffic. This is a figure of a self-healing architecture. Uh, in wireless network communication, bandwidth is higher at shorter range because of interference and other factors that contribute to loss of data as distance increases. One way to get more bandwidth out of the network is to transmit data across multiple short hops. Spatial reuse. In a single hop network, devices must share an access point. If several devices attempt to access the network at once, a virtual traffic jam occurs and the system slows. In a multi-hop network, Many devices can connect to the network at the same time through different nodes without necessarily degrading system performance. Spectrally efficient. By using mesh radio, radio spectrum is used up to 50 times more efficiently because the narrow beams are much less likely to interfere with each other. This enabling mass, massive increases in data capacity for end users at high customer densities. Power. The substrate nodes of mesh network can be built with extremely low power requirements, meaning that they can be deployed as completely autonomous units with solar, wind, or hydropower. Mesh hardware is typically small, noiseless, and easily encapsulated in weatherproof boxes. This is a figure of mesh radio antenna network expansion. With mesh, each network node also acts as a repeater or a forwarding agent for every other network node whose wireless signal it can hear. Because each mesh node plays a dual role, adding additional nodes to the network is very simple. And here are a few disadvantages of a mesh radio. Time-bounded behavior. If you are relaying traffic between a large number of nodes, the latency involved in this relaying can affect time-bounded traffic like voice or radio. This problem is usually addressed via the routing protocol used to implement the mesh, but it is potentially a serious concern regardless. Security concerns. If user traffic is traveling through intermediate nodes in a mesh, security is an issue. Intermediate nodes might be able to eavesdrop on data not intended for them. There are a few other applications of mesh radio. A significant application for wireless mesh network is voice over internet protocol. By this, the wireless mesh may support local telephone calls to be rerouted through the mesh. Voice over Internet Protocol system uses session control protocol like SIP to set up and tear down of calls as well as audio codecs which encode speech allowing transmissions over mesh network as digital audio via an audio stream. Here are some of the current applications used. US military forces are now using wireless mesh networking to connect their computers, mainly rugged laptops, in field operation. It enables troops to know the location and status of every soldier or marine and to coordinate their activities without much direction from central command. Electric meters now being deployed on residences transfer the readings from one to another and eventually to the central office for billing without the need for human meter readers or the need to connect the meters with cables. The 66 satellite Iridium constellation operates as a mesh network with wireless links between adjacent satellites. Calls between two satellite phones are routed through the mesh from one satellite to another across the constellation without having to go through an earth station. This makes for a smaller travel distance. And lastly, the conclusion. Products based on point-to-point and point-to-multipoint topologies may not be well suited for industrial communications. Mesh topology is reliable and redundant, and it can be extended to include thousands of devices. In addition, these networks can be installed in hours instead of days or weeks. Here, I want to end this presentation by saying thank you.